Hello students, this is Indrani ma'am from Rasayan. In this lecture I am going to explain how to find out the products of mixed aldol condensation reaction. Before starting, I am going to explain some important points on aldol condensation. Aldol condensation reaction is acid or base catalyzed reaction between two carbonyl compounds. Two carbonyl compounds may be identical or may be different. If two carbonyl compounds are identical, then self-condensation reaction takes place. If two carbonyl compounds are different, then cross-condensation takes place. For self-condensation, carbonyl compound should have alpha hydrogen. And for cross-condensation reaction, at least one of the carbonyl compounds should have alpha hydrogen. For base catalyzed condensation, dilute aqueous solution of sodium hydroxide, potassium hydroxide, barium hydroxide, potassium carbonate, etc. you can use. And for acid catalyzed reaction, you can use HCl. Now see, this is acetaldehyde, this is acetone. With respect to this aldehydic group, this carbon is alpha, so hydrogens attached to this carbon are alpha hydrogens. And here also with respect to CO, this carbon is alpha, this carbon is alpha, so these are alpha hydrogens. So separately these and these both are having alpha hydrogens. So what are the aldol condensation products here? Since two different carbonyl compounds we are using, so this is example of mixed aldol condensation reaction. Now see here, since this aldehyde is having alpha hydrogen, so here self-condensation product you will get, here also you will get self-condensation product because it is also having alpha hydrogen. One by one we will see. So first we will see self-condensation of two acetaldehyde molecules. This hydrogen attached to this carbon is acidic because adjacent to this carbon one CHO group is present which is electron withdrawing. Therefore base will abstract this proton and we will get this carbon ion. And this H plus and OH minus will form water. Now see, this carbon ion means this is nucleophile. Since oxygen is more electronegative, so this pi bond will cleave in this direction and this carbon ion will attack here. We will get this. Now in the medium water is there, so O minus will capture H plus from here and we will get this beta hydroxy aldehyde or aldol. This by heating removes water, dehydration takes place by heating here and we will get this alpha beta unsaturated aldehyde. This is product number 1 which we are getting by self condensation of acetaldehyde molecule. For each and every case I am not showing the mechanism. How to write the product I will explain. This is protonaldehyde. Now for self condensation between two acetone molecule, what is the product? Just break this bond and this hydrogen will abstracted by base. So what you have to do? Break this bond and add this alpha H. With respect to this ketose, see this is alpha, that alpha H you have to add here. So here other parts you write as it is CH3, CH3, here O minus, this carbon and this carbon will make carbon-carbon bond. Then COCH3 and break this bond and this hydrogen you attach here. Then by heating, dehydration of water takes place, H from here, OH from here, so we will get this alpha beta unsaturated carbonyl compound mesithyl oxide. This is product number 2. Now we will see crossed aldol condensation product, aldol condensation between two different molecules of carbonyl compounds. Now with respect to this carbonyl group, this carbon is alpha, so you break this bond and transfer this alpha hydrogen from here to here. We will get CH3, C, OH, CH. Here this carbon and this carbon will make carbon-carbon bond CH2, CO, CH3. Now if you heat this compound, dehydration takes place, OH from here and H from here will go and we will get CH3, CH double bond, CH, COCH3. this alpha beta unsaturated carbonyl compound. So this is product number 3. Similarly, write acetone first, then acetaldehyde. With respect to this is alpha carbon. So you break this bond and this hydrogen will transfer from here to here. We will get CH3, CCH3, OH, and this carbon and this alpha carbon will make carbon-carbon bond. Here we will get CH2, CHO. Then here also by heating, removal of water takes place and dehydration takes place. We will get CH3, CCH3, double bond CH, CHO, product number 4. Without considering stereoisomers, how many products are there? 4 products are there. Now see, with considering stereoisomers, how many products are there? We have to find out. Now see here, carbon-carbon double bond is there. So here restricted rotation will there. It will show geometrical isomerism because with this double bonded carbon and with this double bonded carbon, 2 different groups are there. So cis and trans. This is one product, this is another product. Both products are possible. In product 2 also, carbon-carbon double bond is there, means restricted rotation is there, but this carbon is having 2 methyl groups. So here GI is not possible. So here this product is possible only. Now see, product 3 is also having carbon-carbon double bond and both the carbons are having 2 different groups. So here GI is possible and this is cis and this is trans. So these are possible. So how many total we are getting? 1, 2, 3, 4, 5. Now we will see what is about product 4. Is there any geometrical isomer or not? So this is product 4 we have seen already. Here carbon-carbon double bond is there, but this carbon is having 2 methyl groups. So here GI is not possible also. So we have seen 5 compounds and this is 1, 6. So considering stereoisomer, 6 products are there. Not considering stereoisomers, 4 products are there. Hope it's clear to you in this video till this. If you like, please subscribe. Thank you for watching.